Hi there and welcome to this video. We are going to discuss the rules of indices. So when you're at Key Stage 3, Year 8, Year 9, you will learn about 3 or 4 of these rules. When you go to Key Stage 4, you will learn 7 in total. That is for higher level. So if you're just Key Stage 3, just have a look at the first 3 rules. That will see you right for Key Stage 3. And if you're doing higher level, have a look at all of the rules. Now, rule number 1 is for when we are multiplying numbers of the same base. So let's have a question. Say 2 cubed times 2 squared. Now you can see that the base is the same because they're both got that number 2 on the ground. The 2, that is going to be the base, and they are the same. The number in the air, this is the power. In this case, it is a 3 and then a 2. Now, another name for power is the exponent or the index, plural indices, or the power. Now, that power just counts how many times you're multiplying the number on the ground, the base, by itself. So let's write these out. 2 cubed is 2 times 2 times 2. And then because in between we are continuing to multiply, we can just carry on with our sum. We are multiplying that by 2 squared. So I've written them all out. Here is my 2 cubed. I'm continuing to times, and here is my 2 squared. So altogether, how many times is 2 being times by itself? 3 for the 2 cubed, 2 for the 2 squared. Let's count them. 1, 2, 3, 4, 5. You don't need to cross them out, but that's just counting them. It is 2 to the 3 plus 2, which is going to be 2 to the 5. So let's do another example. Say we had 5 to the 7 times 5 to the 3. All you would do is add those indices, and that would be 5 to the 10 in total. So generally, a to the m times a to the n, we add the indices. So when the numbers are the same base, you add the indices. Okay, so that is rule number 1. Let's have a look at rule number 2. This is when we're going to be dividing numbers of the same base. So let's have 2 to the 5 divided by 2 squared. So 2 to the 5 just means 2 times by itself 5 times. 1, 2, 3, 4, 5. And we are dividing, so you can put it at the side and use the divide symbol, or like in a fraction, we can just have 2 squared underneath. They mean the same thing. So when you are timesing, dividing is the opposite operation. So the 2 squared on the bottom, we can cancel with 2 of the 2's on the top. So dividing by 2 squared will just undo 2 of the 2's from the top. So what's happened here is it's 2 to the 5 take away 2, because 2 of the 2's on the top will cancel, so we can just take away. So if we had, let's use 5 again, 5 to the 7 divided by 5 to the 3, then we would take away those indices, and that would be 5 to the 7 minus 3, 4. So generally, when we have a to the m divided by a to the n, it is equal to a to the m minus n. We take away. Okay, rule number 3. This is going to be when we have a power of a power. So we're going to see 2 powers. So say we had 2 cubed and we raised that. So all of that number, so that's why I need brackets, all squared. So it's a power of a power. We've got one power, the 2 cubed, and we are raising it to another power. We are squaring. Now squaring means times by itself. So if I wrote this out a different way, I would be doing 2 cubed times by itself. So that means times by 2 cubed again. Now from rule 1, what did we do? We added those indices. So that would be 3 plus 3, 2 to the 6. Now what we've done when we've added there, we have actually got 2 lots of 3, and that comes from here. We are going to be just multiplying those 2 powers in the question. So generally, let's have another example. If we had 5 to the 4 and raise that to the 3, so we had 5 to the 4 all cubed, that would be 5 to the 4 times by 3, which would be 5 to the 12. So generally, if we've got a to the m and we raise it to another power n, you are just going to times those indices together, and that would be a to the mn. You multiply, so we multiply the indices. So they are the 3 rules that you would learn at Key Stage 3. Okay, let's test your understanding and see whether you have understood the first 3 rules. So just a couple of examples. Number 1, what if we had 5 squared times 5 to the 6? What would you do there? Rule number 1 tells us that we have to add those indices. 2 plus 6 is just going to be 5 to the 8. Okay, let's test rule number 2. What if we had 3 to the 7 divided by 3 squared? Rule number 2, can you apply that? Would you be taking away? So 3 to the 7 divided by 3 squared would just be 3 to the 5. Let's see if you've understood rule number 3. What if we had 4 to the 5 and we raise that to the 3? So 4 to the 5 all cubed. From rule number 3, you have to multiply those powers, so that would be 4 to the 15. So we're now going to move on and look at some more rules of indices and look at them individually. These all extend on the ideas we've just had in the first 3 rules. So we're going to have a look at rule number 4, and we're going to look at the 0 index. So for example, 2 to the 0. Now to explain this, we're going to have a look at what sort of sum would give us the answer as a 0 in the index. So if I had 2 cubed and divided it by 2 cubed, I am dividing 2 cubed into itself. Now using rule number 2, we're going to take away those indices, but the index was the same. So 2 of 3 minus 3, it gives us 2 to the 0. But what is 2 cubed? 2 cubed is 2 times 2 times 2, which is 8. So the sum was, we are dividing 8 by itself. How many times does 8 go into itself? It goes 1 time. So by the fact that we have got a 0 in the index here, that just means that we must have had the same number being divided by itself, so that's going to always equal 1. So anything to the power 0 is always 1. So for example, if we had 5 to the 0. What sort of sum could that have come from? Could be 5 to the 10 divided by 5 to the 10. The 0, when we've done that take away, it just means that we were dividing top and bottom by itself. So that is 1. So generally, a to the 0 is always going to be 1. But be careful, what if we had 3x to the 0? It's only the x that is to the power 0, and the x to the power 0, that bit equals 1. So essentially what we are doing is doing 3 times 1, the x to the 0 being 1, so the answer there would actually be 3. Right, next rule, rule number 5, we're going to have a look at negative indices, or the negative index. For example, 2 to the minus 3. What does having a minus as an index mean? So again, we're going to have a little think about a sort of sum that would result in giving us that minus 3. So say I had 2 squared and I divided by 2 to the 5. So this is going to be 2 squared, which is 2 times by itself twice, and we are dividing by 2 to the power 5, 5 2's in the denominator. Now, because dividing undoes timesing, they are the reverse operation, the 2 2's on the top from the 2 squared will cancel with 2 of the 2's in the denominator from the 2 to the 5, and we have ended up with 1 over 2 cubed. But when you have applied rule number 2 and done a takeaway, 2 squared take away 5 is going to give us 2 to the minus 3. So that minus just means that we were left with 2 cubed on the bottom. It was bottom heavy, if you like. So 1 over 2 cubed is the same as 2 to the minus 3. So anything to the minus means that when you did a sum, you had less powers of that base on the top than you did on the bottom, and therefore anything to the minus means 1 over the positive. So for example, if I had 4 to the minus 2, that just means 1 over 4 squared. So the minus just means that it goes underneath. So if we wanted to evaluate that or work out what that was, that would be 1 over 4 squared. 4 squared is 16. So let's do another example, 5 to the minus 3. So what sort of sum could give us a minus 3? You could have had 5 to the 6 divided by 5 to the 9. There were 3 more on the bottom than on the top. So that would give you 1 over 5 cubed. And when you did that take away, 6 take away 9 would actually give us 5 to the minus 3. So 1 over 5 cubed and 5 to the minus 3 are the same thing. So generally, a to the minus m is equal to 1 over a to the m. Next rule, we're going to have a look at fractional indices, a fractional index. So e.g. 3 to the half. Now I'm going to just tell you what this equals and then explain it. Anything to a fraction, the number underneath being 2, this is the same as the square root of 3. So how we're going to explain this? If I had 3 to the half and using rule number 3, I raised it to a power of 2 and squared it. Rule number 3 tells us that we're going to multiply those two powers. So what is a half times 2? Double a half is going to be 3 to the 1, and 3 to the 1 is just 3. So when I have squared 3 to the half, I've ended up with just the number I started with. So it looks like the squaring and the halving undo each other, and they are the inverse operations. So that is why the 3 to the half is the same as the square root of 3. So another example, if I had 25 to the half, that is the same because we've got a fraction as the index and the number on the bottom is 2. So that means the square root of 25, which is actually 5. If I have 8 to the third, notice it's now a 3 on the bottom. So it's not the square root, it is the cube root of 8. And the cube root of 8 is actually 2. So I like to draw a little picture of a tree and then think, where do the roots of the tree belong? They are underneath. So whenever you have a fraction, the number underneath means it is that root. So if we have generally a to the 1 over m, that is going to be the same as the m root of a. Rule number 7 is just another extension of rule number 6, fractional index, but we're now going to have a look at when the fraction is not a unit fraction, it can have another number than 1 in the numerator. For example, 8 to the 2/3. Now we already know that the 3 on the bottom means root. What does it mean having the number 2 on the top? Well, that just means the normal power. So when you have a unit fraction and that number's 1, anything to the 1 is just itself, so you don't really need to do anything when it's a 1. But when it is other than a 1, you have to raise it to a power. Now it doesn't really matter which order you do these in. Let's have a look at these both ways. This is telling us to do the cube root of 8 squared. Well, I know that the cube root of 8 is 2, and then hold that answer and square it, and that will be 4. But you can also do 8 squared first, which is 64, and then cube root that. The cube root of 64 is also 4. So it doesn't really matter which order you do them in, but usually we can root things first. So if we had 64 to the 2/3, I need to do root on the bottom and power on the top. Now, I don't know what 64 squared is off the top of my head, but I do know that the cube root of 64 is 4. So holding that answer and doing that one first, cube root of 64 is 4 and 4 squared is 16. So you're going to do it the order that you know how to do. So generally, a to the m over n is going to equal the nth root of a to the m. Okay, let's test your understanding on the next set of rules, the next 4. Let's have a look at number 1, 10 to the 0. Can you remember what anything to the 0 is? Anything to the 0, rule number 4, is always 1. Okay, next rule was negative indices. So what if we had 6 to the minus 2? Have you remembered? Anything to the minus means it's 1 over the positive. So 6 to the minus 2 means 1 over 6 squared. And if you're asked to evaluate that, that would be 1 over 36. Number 3, fractional indices. So what about 49 to the half? Have you remembered that when it's a fraction, the denominator means root? So this is the same as asking you what is the square root of 49, and the square root of 49 is 7. Okay, number 4. What if we had 16 to the 3 over 2? So have you remembered that on the bottom means root, and because it's a 2, this means square root. So we need to square root 16, which is 4, and then we need to cube 4, which is going to be 64. Okay, now it's your turn to really test your understanding. This is a mixture of all the rules. Some of them are quite difficult. Have a go at them, press pause and have a go, and then press play to see if you've got them right. Best of luck. Question 1. Did you add the indices? 6 plus 7 is 13, so this is m to the 13. Anything to the 0 is 1. Part C, you have to take in that half, so it applies to everything inside the bracket. 16 to the half is going to be 4, and 6 times a half was going to give you y cubed. For number 2, normal rules of division will apply for the 15 and the 3. So 15 divided by 3 is 5, and then you have to apply rule 2 and do a takeaway, so you're going to have y to the 4. Normal rules for multiplication for the 7 and the 3 give you 21. W to the 1 then times by w cubed is going to be w to the 4, adding those indices, and then x squared times by another x is going to give you x cubed. Number 3, we have to multiply, so that would going to give you 2 to the power 6, and it's asking you to work it out. So 2 to the power 6 is going to give you 64. Squaring and rooting will cancel each other out, so that's just going to give you 3. 2 to the power 4 is going to be 16 times 9, and that's all under the square root. 16 times 9 is 144, and we want the square root of 144, which is 12. 4 to the minus 2 means 1 over 4 squared, and that is going to be 1/16. Evaluate, that means the same as work out. So 3 to the minus 2, again, it's going to be 1 over 3 squared, putting that minus underneath, so that's 1/9. 16 to the 3/4, the 4th root of 16 is 2, and 2 cubed is 8. When you've got this 200 to the square root of 200 and square root of 8, you've really got 200 divided by 8 all square rooted. So that's all being raised to the power half. You can take that root over the whole lot because it's happening to top and bottom. Doing the division, 200 divided by 8 is square root of 25, which is 5. So that's going to involve a bit of knowledge of surds as well to do that one there. Number 5, 8 to the 2x plus 3 in the form of 2 to the y. Well, this is all about putting that 8 as a power of 2. So we need to change that 8 into a power of 2, and I know that 2 cubed is 8. So replacing the 8 with 2 cubed and then raising it to that power 2x plus 3, and then using rule number 3, we need to multiply those together. So it's going to be 2 to the, you have to multiply 3 by 2x and 3 by 3, so it's the 6x plus 9. So in terms of that equaling 2 to the y, we can see that the power, the 6x plus 9, is equal to the y. So stating y in terms of x just wants you to say that y is equal to 6x plus 9. Equating those powers once we've got the number on the ground, the base the same. Number 6, 16 to the minus quarter. Well, the minus just means it will be 1 over 16 to the quarter. That's dealing with the minus. And then the quarter, the 4 being in the denominator, means root. The fourth root of 16 is 2. So that's actually just a half. Part B, the power 4 is only acting on what's inside the bracket. So we need to do 2 to the 4 and 2 to the x to the minus quarter all to the 4 and leave that x on the front for now. So it's x, and then inside the bracket 2 to the 4 is 16 and x to the minus a quarter times 4. So you've got minus a quarter times 4. The 4's will cancel out and you'll just have x to the minus 1. So that will equal x times 16. Now x to the minus 1 means 1 over x to the 1, and the x's top and bottom will cancel and you'll just have the answer 16. Number 7, given that 32 square root of 2 is 2 to the a, well, like we replaced the 8 before as a power of 2, 32 is a power of 2. You should know your powers of 2 up to about 5 or 6. So 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, times by 2 again, 2 to the 4 is 16, 2 to the 5 is actually 32. So we can replace 32 with 2 to the 5, and then the square root of 2 is 2 to the half. So then using that rule number 1, you can add those indices. So that will be 2 to the 5.5, which is equal to 2 to the 11 over 2. So A is equal to 11 over 2 or 5.5. Write down the value of 125 to the third. The third root of 125 is just going to be the cube root of 125, which is 5. Find the value of 125 to the minus 2/3. We've already dealt with the 3 on the bottom, that's 5. So we have to deal with the minus and the squared. So the minus just means it's going to go underneath. So we've dealt with the minus. The cube root of 125 is 5, and then holding that answer, 5 squared is 25. So altogether, that will be 1 over 25. Really well done. If you managed all of those, you are on your way to succeeding and being good at indices. Well done. Thank you so much for watching. Hopefully that has furthered your understanding of indices. If you've liked the video, please do like and subscribe, and I'll see you on another video.